Sir, you're on mute.
Thank you, ma'am. All right.
Yes, sir, thank you.
All right. Thank you, ma'am. All right. Sorry, students, I was on mute. Okay. So what I was talking is, let's do some problems on friction. All right. Let's see how to tackle friction. And then morning we have seen a particle moving on a plank, and we have seen the trajectory of the particle with respect to ground and with respect to plank. All right. So now let us have got a block projected with velocity v naught. So direction of friction will be, this is ground. So to determine the direction of friction, I need relative velocity. Velocity of block with respect to ground. I'll stand on the surface on which the block is moving. Block is moving on this surface, so I'll stand on this surface and I'll observe the block. Block is moving towards right, friction will act towards left. What kind of friction it is? Kinetic friction. So Fk is towards left. And Fk is always given by mu n times minus Vr cap. So if mass is m naught, normal reaction is n, gravitational force is m naught g. So vertically there is no motion. So I can write n is equal to m naught g, or n minus m naught g is equal to 0. So n is equal to m naught g. I got normal reaction. I'll plug this normal reaction here. All right. Coefficient of friction is given. Coefficient of kinetic friction or coefficient of friction is given. If not mentioned that whether it is static or kinetic, it means static coefficient of friction, coefficient of static friction, and coefficient of kinetic friction are same. All right. Okay. Now, so I'll plug this normal reaction in this one. So I'll get force is equal to mu mg directed opposite direction of velocity. So F is equal to mu m naught g is equal to mass into acceleration. Right? Force is equal to mass into acceleration. M naught gets cancelled out. So A is equal to mu into G. Look at this. M got cancelled out. That means my acceleration, because of kinetic friction, when a particle is projected with the velocity v naught, my friction is independent of velocity, that's obvious. It only depends on the direction of velocity. If the direction of velocity is towards right, friction is towards left. And the magnitude of friction is mu mg, which is the cause of acceleration, which is equal to mu m into A. M gets cancelled out, A is equal to mu into G. If you look at this acceleration, it is independent of mass. That means 100 kg mass or a 10 kg mass will retard with the same acceleration mu g. All right. So acceleration of the particle now is mu g towards left. So velocity is towards right, acceleration is towards left. So particle will retard. That is also obvious because kinetic friction will try to bring the particle to rest with respect to the surface on which it is moving. It will try to reduce the relative velocity of the particle. So relative velocity is towards right. It will go on retarding with respect to the ground and it will eventually stop. So once it stops, kinetic friction disappears because it depends only on the relative velocity. Relative velocity becomes zero, kinetic friction disappears, and there is no force acting on the particle. So what happens now? What happens to the velocity? Velocity decreases as v is equal to v naught minus mu gt. With respect to time, it varies like this. V naught v t. So is this graph correct, students? And after what time will it stop? Equal to 0. So V naught by mu g is the time after which it will stop. V naught by mu g is the time after which the particle stops. Is this graph correct? Is the question. Y is equal to mx plus c is the equation of the graph. Is this graph correct? Say yes or no. Is the velocity time graph correct?
Yes,
Correct?
Yes, sir.
Huh? I say it is not correct. It is not. It is.
It is correct, sir.
Sorry.
It is correct.
Sorry, Bhaskar.
It is correct.
It's correct.
Graph.
Okay. Okay. But look at this. After time t, v naught by mu g, what happens? This particle retards. Let's say it stops somewhere here. After stopping, is the velocity reverse? Will the particle reverse in direction? No.
No, sir.
So that means this part of the graph is not correct.
Yes,
Once
sir.
it stops, its velocity becomes. So this is correct. It drops to zero, then remains zero. So it doesn't become negative.
Why, sir?
See, particle is moving towards right with velocity v naught. Retardation is mu g, and that is because of friction, kinetic friction. Because of this retardation, particle slows down. It eventually stops. It will eventually stop, right? Once it stops, what is the velocity? V equal to zero. Final velocity is zero. When the velocity is zero, what is the friction? Kinetic friction? Zero.
Zero, sir.
Zero.
Zero. Once the friction is zero, force is zero. Force is zero, acceleration is zero. Velocity is zero, acceleration is zero. That means the particle will remain there itself.
Okay,
Yes.
sir. Understood.
Right? So velocity becomes zero, it will remain zero forever after that because kinetic friction disappears. Till then, there is a force acting, which is a constant force acting mu mg, because of which there is a constant acceleration mu g, because of which there is a retardation, v naught is decreasing continuously till it becomes zero. Once it becomes zero, it doesn't turn back because acceleration disappears. The moment it becomes zero, acceleration disappears. So my velocity time graph is this way. It drops linearly, and then once it becomes zero, it remains zero. Okay.
Yes, sir.
Okay. Now look at this one. I'll put another situation. There are two blocks. One is a plank, which is moving the velocity 6 meters per second. All right. And there's a block which is projected with velocity 10 meters per second. And this is moving with constant velocity somehow. All right. I'm pulling this with constant velocity, on which I've thrown a block. Okay. Block ni push చేసి వదిలేసాను with a velocity of 10 meters per second. All right. Coefficient of friction is mu. Mass doesn't matter because it is independent of the mass. My friction, when particle is only projected with velocity, some velocity, all right, mass m అనుకుందాం. You see that mass gets cancelled out. Now I have to find out. I have to again plot v versus t graph. ఇప్పుడు ఎలా plot చేస్తాను? This 10 goes on decreasing. This is 10 with respect to ground. All right, this 10 is with respect to ground. So as long as 10 minus 6 is towards right, so my friction is towards left. If friction is towards left, this friction will try to reduce this 10 and bring it to 6. Relative motion is zero just the friction, kinetic friction. Kinetic friction always makes the relative velocity zero. Tries to make the relative velocity bring it to zero. So ఇది 10 ఉంది కదా, ఇది 6 ఉంది. What is the relative velocity 4? It will bring it to zero. That means this 10 will reduce to 6. So once it reduces to 6, both will go together with 6 and friction disappears. The moment this 10 becomes 6, friction disappears and it will continue to move with 6. So my graph would be v naught నుంచి 6 వరకు వస్తుంది. 6 నుంచి కాన్స్టెంట్ గా 6 ఉంటుంది. ఈ గ్రాఫ్ అర్థమైందా? With respect to ground, particle velocity of the plank is 6. So relative velocity 4 ఉంది. That relative velocity goes on decreasing. Once the relative velocity becomes zero, kinetic friction disappears. And the particle, there's no force acting on the particle. Particle will continue to stay there or stay on this plank. And with respect to ground, it continue to move with velocity of 6 meters per second together with the plank. Is it okay? అయితే వెలాసిటీ టైం గ్రాఫ్ ఇలా వస్తుంది. 10 నుంచి 6 వరకు స్లోప్ మ్యూజీ అని ఉంటుంది. ఇంతకు ముందు స్లోప్ ఎలా ఉంది? మ్యూజీ ఉంది, మైనస్ మ్యూజీ, నెగటివ్ స్లోప్ ఉంది. ఇప్పుడు కూడా నెగటివ్ స్లోపే ఉంటుంది. సేమ్ ప్యారల్ లైన్ ఉంటుంది. దానికి కూడా దానికి దీనికి లైన్, ఆ లైన్ కి ఈ లైన్ ప్యారల్ ఉంటుంది. బట్ it will drop from 10 to 6 and remain at 6 forever. All right, provided I keep this with moving with constant velocity 6. All right, ఇది కూడా ఇక్కడ constant velocity ఇది లేకుంటే things are different. That will do it later. But I am somehow pulling this with constant velocity. ఇది what is that called? Belt అనుకోండి, which is moving constant velocity 6. Then దానిపైన నేను ఒక బ్లాక్ ని ప్రొజెక్ట్ చేశాను 10 meters per second తో with respect to ground. So velocity of this with respect to belt is towards right, so friction will be towards left. That means this friction will retard the particle. It will bring from 10 to 6. Once the velocity is 6 meters per second, velocity of this with respect to the plank is 0. Once the relative velocity is 0, my kinetic friction disappears. Once kinetic friction disappears, acceleration disappears. I mean, the acceleration is the effect of cause. I mean, force disappears and effect would disappear. That means it will remain 6 forever. Do you understand this graph?
Yes, sir.
Okay. ఇప్పుడు చూడండి, ఒక మాస్ ఉంది, 10 kg మాస్. కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ 0.1 అనుకుందాం. 0.1 0.2 అనుకుందాం. All right. So what is the normal reaction over here? 10g. Normal reaction is equal to 10g. Right?
10G.
Right.
Yeah.
10g. So what is the limiting friction I told you? Limiting friction is mu s into n. If I don't mention mu s and mu k, that means mu s is equal to mu k. So limiting friction is Fl is equal to 0.2 into 100, which is 20 Newton. So limiting friction is 20 Newton. If I now apply 5 Newton's force, will the block move? Block move. Yeah, friction over here is no, it doesn't move. That's good. Friction over here is self-adjusting. ఇప్పుడు static friction గురించి మాట్లాడుతున్నాను. Look, I didn't give any velocity to the particle, so kinetic friction doesn't come into picture. When the particle is at rest with respect to the surface, static friction comes into picture. Static friction ఉన్నప్పుడు static friction counterbalances the external force applied. ఈ 5 Newton ఏం అప్లై చేయలేదు అనుకుందాం, అప్పుడు static friction ఎంత ఉంటుంది? 0 ఉంటుంది, because net force on that should be 0. Net external applied force is 0. So there's no force required to counterbalance any external force, because there's no external force. So no counterbalance force is required. So friction is 0. Static friction is self-adjusting. Kinetic friction లాగా సింపుల్ కాదు. Kinetic friction ఎలా ఉంటుంది? Relative velocity కనుక్కోవడం, దాని ఆపోజిట్ పెట్టేయడం, and magnitude mu into n. Static friction అలా కాదు. You have to find out the external force. You have to counterbalance the external force. External force ఇప్పుడు 5 Newton పెడితే, so I have to counterbalance this external force. Can the friction counterbalance is what I have to think. Can the friction counterbalance? Yes, because 20 Newton capacity on the limiting value is 20 Newton. Friction's capacity to handle external force is 20 Newton.
Yes, sir.
20 Newton వరకు అపోజ్ చేయగలుగుతుంది. బట్ ఇది 5 Newton ఉంది, సో ఇట్ విల్ సెల్ఫ్ అడ్జస్ట్ టు 5. ఇది 6 Newton చేస్తే ఇట్ విల్ సెల్ఫ్ అడ్జస్ట్ టు 6, కొంచెం ఇంక్రీజ్ అయ్యి. ఇది 7 Newton చేస్తే ఇది కొంచెం ఇంక్రీజ్ అయ్యి 7 అయిపోతుంది. ఇది 10 చేస్తే ఇది కూడా 10 అయిపోతుంది. ఇది 20 చేస్తే ఎగ్జాక్ట్లీ 20 అయిపోయి ఇట్ ఈస్ అట్ ద వర్జ్ ఆఫ్ స్లిప్పింగ్. 20 ప్లస్ డెల్టా చేశాను అనుకోండి, 20 ప్లస్ డెల్టా 20.1 కూడా చేస్తే, this is limiting is 20, it cannot further increase, it will start slipping,
Yes, sir.
it will start moving. All right. So my question now is, if I give 10 kg block ke 0.3 ఇచ్చాను, coefficient of friction is 0.3, coefficient of static friction is 0.3, applied force is 20 Newton. Will the block move?
No, sir.
No, sir.
No. All right. What is the acceleration of the block?
13 Newton, sir.
30 Newtons, sir.
Yeah, that's the limiting value, right?
Yes, sir.
So block is under 20 Newton applied చేస్తే what is the friction value then?
20 Newtons,
20
sir.
Newton.
20 Newton. Limiting value is 30, but it is
Yes.
self-adjusting. It will adjust to 20.
Yes, sir.
Yeah, that's good. That's good. All right. Now, if I make this 35, అప్పుడు ఎంత ఉంటుంది?
30 Newton, sir.
Sir, it will
30
move
Newton. It will move. That's good. It will move. And friction ఎంత ఉంటుంది అప్పుడు?
30 Newtons, sir.
30 Newton. So net force ఎంత ఉంటుంది? Fx direction లో 35 minus 30 is 5 Newton. Acceleration కావాలంటే Fx by mass m divided by mass m 5 by 10, which is 1 by 2 meters per 1 by 2 meters per second square.
Yes, sir.
All right. అది 40 చేసాను అనుకోండి ఇది, అప్పుడు యాక్సలరేషన్ ఎంత ఉంటుంది?
1, sir.
Sir.
1, sir.
Yes, that's 1. That's 1. Absolutely right. ఇప్పుడు 40 ఇలా అప్లై చేస్తాను, 20 ఇలా అప్లై చేస్తాను, అప్పుడు ఏముంటుంది ఫ్రిక్షన్? ఫస్ట్ నెట్ ఎక్స్టర్నల్ ఫోర్స్ కనుక్కోవాలి. నెట్ ఎక్స్టర్నల్ ఫోర్స్ కనుక్కున్నాక then you have to see whether
Sir, friction 20 Newtons.
which direction.
Left side direction, sir.
Sir, left.
Right. That's very fast. That's very quick and very good. I'm happy. So 40 net force ముందు first I'll presume it's frictionless. Frictionless అనుకోని net force కనుక్కుంటాను. Net force ఏంటి? 40 minus 20 is 20 towards right. So my friction, I'll see whether it is able to counterbalance that or not. My limiting friction is 30.3 అనుకుంటే coefficient of friction. Limiting friction is 30 Newton. So external is only 20, so I can counterbalance. It is my capacity, it is the block's capacity, I mean, it is the surface capacity to counterbalance that force. So it will counterbalance. It will self-adjust to 20 and counterbalance. So block will not move. అదే ఇక్కడ కూడా 40 అప్లై చేశాను అనుకోండి, ఇది కూడా, అప్పుడు ఫ్రిక్షన్ ఎంత ఉంటుంది?
0, sir.
0 Newton, sir.
జీరోనా?
Yes, sir. 0.
Yes, sir.
All right, good. If it is 80,
Sir,
40, sir.
right, sir. Towards right.
towards right, ఎంత ఉంటుంది? Will the block move? Limiting value is only 30, all right? Limiting value is only 30 Newton.
Yes, sir.
So friction is towards right, that's right. ఎంత ఉంటుంది ఫ్రిక్షన్ ఇప్పుడు?
30 ఉంటుంది, sir.
30, sir. 30 Newtons.
ఎందుకు 30? 40 ఎందుకు కాదు?
Limiting value 30 ఉంది కదా, sir.
Right,
Friction.
limiting value reach అయిపోయింది. Right, it cannot extend beyond that. It can self-adjust to an extent of limiting value. Once limiting value is reached, it cannot self-adjust anymore. It will become constant after that. So 30 ఇది ఉంటుంది, ఇది ఎంత ఉంటుంది? Net force 40. Acceleration ఎంత ఉంటుంది? 40 minus 30 by 10. So అది ఎంత ఉంటుంది? 1 meter per second square towards left.
Yes, sir.
Okay, that's very good. But now look at the scenario. I project a particle here with velocity v naught is equal to 10 meters per second. All right. And I apply a force, constant force of 10 Newton. Mass is 10 kg. ఇప్పుడు ఫ్రిక్షన్ ఎలా ఉంటుంది? ఏ డైరెక్షన్ లో ఉంటుంది? The moment you see velocity, you should think of kinetic friction, not static friction.
Right, sir. Towards right. Friction.
Yes, friction is towards right. ఎంత ఉంటుంది? mu value 0.3 ఇచ్చాను అనుకుందాము.
ఉంటుంది, sir.
0.3 ఉంది. Mu value 0.3. See, it is moving, right? So kinetic friction comes into picture. If velocity is 0, then static friction comes into picture. But the moment it is moving, it becomes simple. Kinetic friction is simple to handle.
So if you don't mind, can you explain?
Yeah, sure. Why would I mind? I'm happy to explain. All right, look at this.
So, sir, is it
Yes,
30 newtons friction?
yes, 30 Newton towards right.
Yes, sir.
That's absolutely right. Good. Now look at this. Velocity channel. Velocity channel ante particle is moving towards left with respect to the surface. Once there is motion with respect to the surface, once there is relative motion, kinetic friction comes into picture, which is given by Fk is equal to mu n into mu n times Vr cap. That means velocity is towards left, relative velocity is towards left, kinetic friction is towards right. So kinetic friction is towards right. What is kinetic friction value? It doesn't depend on your external force now. No matter whether you apply force or not, my kinetic friction is mu n. So how much is mu n? 0.3 into 100, which is 30 Newton.
Yes, sir.
Yeah, that's what you did?
Yes, sir.
All right. Good. Vignesh, did you understand?
Yeah, sir.
Okay. All right. So now let us find out the acceleration of the particle. I project the particle velocity v naught. I have to find the acceleration of the particle. Friction ఎంత ఉంది? Applied force 10 ఉంది. So net force is 40. దీన్ని 20 చేసేస్తాను. Sorry. Applied force 20 చేసేస్తాను. All right. Simpler calculation. So applied force is 20. Friction is 30 towards right. So net force is 20 plus 30, 50. 50 by 10 is acceleration, which is 5 meters per second square. So acceleration is towards right of 5 meters per second square. Velocity is towards left. ఇప్పుడు ఏమవుతుంది పార్టికల్? రిటార్డ్ అవుతుంది. Right? Do you all agree? Particle will retard. It will go towards left, stop. Let us see what happens after stopping. But ఇది అర్థమైందా? It will go towards left and stop అని అర్థమైందా మీకు?
No, sir.
Okay. చూడండి 20 is my force towards applied towards right. But because it has velocity, I've got nothing to do with applied force. Kinetic friction ఖచ్చితంగా యాక్ట్ అవుతుంది, which is mu n times minus Vr cap. అది ఫోర్స్ అప్లై చేసినా లేకున్నా మై కైనెటిక్ ఫ్రిక్షన్ విల్ యాక్ట్, బికాస్ కైనెటిక్ ఫ్రిక్షన్ డిపెండ్స్ ఓన్లీ ఆన్ ద రిలేటివ్ వెలాసిటీ. ఇక్కడ రిలేటివ్ వెలాసిటీ ఉంది, కైనెటిక్ ఫ్రిక్షన్ వచ్చేస్తుంది. ఇప్పుడు వెలాసిటీ కైనెటిక్ ఫ్రిక్షన్ వచ్చేసాక వాట్ ఇస్ ద నెట్ ఫోర్స్ నౌ? 30 Newton ఫ్రిక్షన్ ఇస్ టువర్డ్స్ రైట్, 20 Newton applied is towards right, total force is 50 Newton. So F applied is 50, mass is 10, F by m is acceleration. Acceleration is 5 meters per second square. Is it okay?
Yes, sir.
ఇప్పుడు చూడండి, velocity is towards left, acceleration is towards right. They are linear, one dimension motion. ఇది towards left ఉంది, ఇది towards right ఉంది. So particle will retard. Whenever acceleration and velocity are opposite in direction, particle will retard, na?
Yes, sir.
So ఇది left కి వెళ్ళి left కి వెళ్ళి ఆగిపోతుంది. Do you all agree with that?
Yes, sir.
ఆగినాక ఏమవుతుంది చూద్దాము. But do you agree that it will go and stop eventually? Do you all agree that it will go and stop eventually, students?
Yes, sir.
How, sir?
చూడండి, v0 10 ఉంది కదా, వెలాసిటీ టువర్డ్స్ లెఫ్ట్ ఉంది, యాక్సిలరేషన్ టువర్డ్స్ రైట్ ఉంది. వెలాసిటీ తగ్గుతుంది 0 అయిపోతుంది. సో 0 అయిపోయిన తర్వాత ఏమవుతుంది మాట్లాడదాము, బట్ 0 అవుతుంది కదా.
Yes, sir.
వెలాసిటీ 0 అయితే అవుతుంది, ఏదో ఒక టైంకి 0 అవుతుంది. ఏ టైంకి అవుతుంది? v is equal to 10 minus at, 5 into t equal to 0, t equal to 2 seconds. After 2 seconds, particle will stop. The moment it stops, my kinetic friction disappears. Now comes the interesting part. చూడండి ఇప్పుడు ఏమవుతుంది, the moment it stopped, let's say it stopped over here, kinetic friction will disappear. Do you all agree?
Yes, sir.
Once it disappears, because there is some external force applied acting on it, 20 Newton, static friction will come into picture. Static friction వస్తే I will see the net applied force. Net applied force is less than limiting friction. Limiting friction ఎంత ఉంది 30, but applied force is only 20. So my static friction will self adjust to 20 and counterbalance is 20. So particle remain at rest. Force apply chesina kuda it will remain at rest because my static friction coming into picture is less than the limiting friction. My applied force is less than the limiting friction, so I can self adjust. My static friction can self adjust so as to counterbalance the applied force. అర్థమైంది అది? I'll repeat, not a problem. Velocity towards left ఉంది, acceleration towards right ఉంది. ఈ సినారియో ఫైన్. దిస్ సినారియో ఇస్ ఓకే, ఇక్కడ వరకు ఫైన్. బట్ ఇక్కడ దీని తర్వాత ఏమవుతుంది? వెలాసిటీ రిడ్యూస్ అవుతూ వెలాసిటీ జీరో అయిపోతుంది. వన్స్ వెలాసిటీ ఇస్ బికమింగ్ జీరో, kinetic friction disappears. Now the role of static friction comes into picture.
సార్ యాక్సలరేషన్ ఏమైతుంది సార్?
చూడు ఏమవుతుంది, ఇది ఇది 0.1 మీటర్ పర్ సెకండ్ వరకు వచ్చింది అనుకుందాము. ఫ్రిక్షన్ వల్ల అప్లైడ్ ఫోర్స్ వల్ల ఇంకా మూవ్ అవుతుంది. 1 మీటర్ పర్ సెకండ్ 10 నుంచి 1 కి తగ్గింది. ఇంకొంచెం ముంగట వెళ్ళి జీరో అయిపోతుంది. ఇది 0 మీటర్ పర్ సెకండ్ అయిపోతుంది, ఆగిపోతుంది పార్టికల్. పార్టికల్ ఆగినప్పుడు kinetic friction will disappear. I told you, right? If Br cap is 0, kinetic friction is 0.
Yes, sir.
Kinetic friction 0 అయిపోతే, if there were no force applied, this would remain at rest forever. And static friction will also be 0 because there is no external force acting on it. But what I said, there is an external force of 20 Newton acting on it.
సార్ యాక్సలరేషన్ కూడా ఉంది కదా సార్?
Acceleration disappear అయిపోయింది కదా. Friction disappear అయిపోతే acceleration disappear అయిపోయింది కదా. That moment when friction disappeared, acceleration, that moment is 0, but this is 20 is there. Kinetic friction disappear అయిపోయింది, right?
Yes, sir.
Kinetic friction disappear అవ్వగానే static friction will come into picture. Static friction will counterbalance is 20 because its capacity is 30, applied is only 20. I will count static friction will counterbalance this one. Net force becomes 0. Acceleration is round with 0. That's okay, take time, but it's a good one. It's a good question. ఇలాంటి వచ్చాయి ప్రీవియస్ మెయిన్స్ లో. Bhavna, is it okay?
Yes, sir.
Okay, no, be confident. I mean, be sure. If you're not sure, I'll tell you again. Others, everyone?
Yes, sir.
Okay. So I presume everyone has understood, but I'll quickly repeat this. 20 Newton act అవుతుంది, but velocity వల్ల kinetic friction వచ్చింది. Kinetic friction is towards right because velocity is towards left. So net force acting on the particle is 20 plus 30, 50 towards right. That 50 is producing an acceleration of some 5 meters per second square. This 5 is retarding the particle because velocity is towards left, acceleration is towards right. Because the particle is being retarded, particle is slowing down, it will eventually become 0. Velocity will eventually become 0. But the moment it becomes 0, kinetic friction disappears and static friction will come into picture. And how will the static friction be? That friction will be counterbalancing the external force. If it has the capacity to counterbalance, it will counterbalance. Yes, it has the capacity because capacity is 30 Newton, limiting is 30 Newton, and applied force is only 20 Newton. So static friction immediately come into picture and counterbalances force. So acceleration remains 0. అది పార్టికల్ ఆగంగానే యాక్సిలరేషన్ 0 అయిపోతుంది. సో పార్టికల్ రిమైన్ దేర్ ఇట్సెల్ఫ్, ఇట్ విల్ నాట్ మూవ్. సో వీటీ గ్రాఫ్ ఎలా ఉంటుంది? 10 నుంచి 2 seconds వరకు ఇలా కిందకు వచ్చి మళ్ళీ ఇలా వచ్చేస్తుంది పార్టికల్, అక్కడే ఉంటుంది పార్టికల్. వెలాసిటీ రిమైన్ 0. నౌ లెట్ us look at this one. ఇది అర్థమైంది కదా అందరికి?
Yes, sir.
Now let us say instead of this one 20, I'm applying a force of 40. All right, I'm applying a force of 40. అప్పుడు ఏమవుతుంది చూద్దాం. So net force is now Again, I'll begin from beginning. Velocity undante with respect to surface, static friction doesn't play any role because there is relative motion. Whenever there is relative motion, kinetic friction వచ్చేస్తుంది. Kinetic friction has got a limiting value or fixed value, which is mu into n, which is 30 Newton in this case. 30 Newton towards right. Why is it towards right? Because velocity is towards left. Velocity of the particle with respect to the surface on which it is moving is towards left. Friction is towards right. Friction opposes the relative motion of radial velocity of the particle. Radial velocity left ఉంది, velocity of the block with respect to the surface left ఉంది, friction will be towards right. Right ఉంటుంది. Right. That's 30. Applied force is 40. So net force is 70. Acceleration will be 70 by mass, which is 7 meters per second square. ఇప్పుడు acceleration ఎక్కువ అయింది. So it will stop after some time. All right. It will stop after a time of 10 by 7 seconds. All right. That's a different story. That's kinematics. But the moment it stops, what happens? Kinetic friction disappears. But because this is 40, applied force is greater than how much static friction can handle. My limiting value will come into picture because static friction can only handle 30, but applied is 40. It will try as much as it can by setting itself to 30, and net force is now 40 minus 30. Block will start moving towards right.
Yes,
Block will start
sir.
moving towards right. So with an acceleration of 1 meter per second square. And 40 minus 30 is 10. 10 by 10 is 1. All right. Now, ఈ వెలాసిటీ టైం గ్రాఫ్ ఎలా ఉంటుంది చూద్దాము. 10 నుంచి 0 అవుతుంది. 0 అయిన తర్వాత ఏమవుతుంది? పార్టికల్ ఇస్ రివర్సింగ్ ఇట్స్ వెలాసిటీ.
Yes, sir.
సో ఎలా ఉంటుంది గ్రాఫ్? కెన్ యూ జస్ట్ థింక్? ఓ సారీ, ఇది వెలాసిటీ నెగటివ్ తీసుకున్నావు కదా. ఐ ప్లాట్ ఇట్ లైక్ దిస్. -10 నుంచి 0కి వచ్చింది. ఇప్పుడు ఇక్కడ నుంచి ఏమవుతుంది? ఇంతకుముందు -10 నుంచి 0కి వచ్చేసి ఆగిపోయింది అప్పటికి. బట్ ఇప్పుడు వాట్ హ్యాపెన్స్ నౌ ఇస్ -10 to 0
పైకి వెళ్తుంది సార్.
రైట్, పైకి వెళ్తుంది. విత్ వాట్ స్లోప్? సేమ్ స్లోప్? నో, విత్ లెసర్ స్లోప్. బికాస్ స్లోప్ లెఫ్ట్కి వచ్చినప్పుడు స్లోప్ ఎంత ఉంది? 7 ఉంది. రైట్, యాక్సలరేషన్ 7 meters per second టువర్డ్స్ రైట్. ఇప్పుడు ఎంత ఉంది? 1 ఉంది. సో ఈ స్లోప్తో వెళ్తుంది. ఇట్ విల్ బి లెసర్ దెన్ దిస్ స్లోప్. ఈ స్లోప్ 7 అంటే దిస్ విల్ బి లెస్ దెన్. ఇట్ ఇస్ నాట్ 7. అప్రాక్సిమేట్, లైక్ ఇఫ్ యూ సే దిస్ ఇస్ 7, దిస్ విల్ లెస్ దెన్ 7. 1, ఇది 1 ఉండాలి. Or more, like if I draw it to scale, I'll draw it properly. This is 10 by 7. This angle is 45 degrees. VT. ఈ స్లోప్ 1 ఉంటుంది. This is slope of 7. All right.
Yes, sir.
Okay. Okay, good. Now, okay, one second. Before this. There's a string here. There's a surface, frictional surface, not frictionless surface. Some force is applied here, F. Tension over here, which appears as T. Friction, coefficient of friction is mu. And mass of the block is M. I have to plot tension as a function of F. F is gradually increasing. F 0 నుంచి small values to gradually increase అవుతూ increase అవుతుంది. All right. And presume this thing is ideal, which doesn't break. Its breaking strength is very high. So I have to plot T versus F. So see what happens in this case is, if there were no friction, tension would be equal to F. And as soon as you apply force, tension would appear here. The moment you apply force, tension would appear here, and this mass would be at rest. But when there is friction, tension doesn't come into picture first. Friction comes into picture. It will self-adjust itself to counterbalance F. Then when this reaches limiting, when it cannot anymore counterbalance F, then tension comes into picture to counterbalance F. What I mean to say is, F ఇలా ఇంక్రీజ్ అవుతూనే ఉంటే ఇది T ఉంది. So friction is F, if F is very small. Let's say F naught is limiting friction. F is less than F naught అనుకుంటే, if F is less than F naught, that means my friction, static friction over there will be equal to F till this reaches F naught value. So tension is 0 till my external force reaches limiting value, FL అనుకుందాం better. Alright, limiting friction is FL. Till FL is less than F is less than FL, my static friction counterbalances this one and tension is not required. So tension picture లోనే రాదు. So tension is 0 till F is reaching this FL. ఒకసారి FL reach అయినప్పుడు, once it crosses FL, static friction has got a limit now. It cannot increase further anymore. That time tension will come into picture. So T plus FL is equal to F. So T is equal to F minus FL. This is my equation of the graph. Y is equal to mx plus c. Y is equal to mx plus c ante x mx, m is 1 plus c ante minus 1 minus FL. Y is equal to x graph ni kinda FL తో pull చేస్తారు. This is my tension versus applied force graph. ఇది అర్థమైందా అందరికి? స్టూడెంట్స్ అర్థమైందా?
సార్ అది గ్రాఫ్ అర్థం కాలేదు సార్.
ఓకే ఓకే, చూడు, ఎప్పుడైనా గ్రాఫ్ కోసం ఈక్వేషన్ కావాలి. నేను చెప్పాను, స్టార్టింగ్ నుంచి చెప్పాను, గ్రాఫ్ కోసం మనకి ఈక్వేషన్ కావాలి. ఆల్రెడీ ఇప్పుడు ఈక్వేషన్ v = మైనస్ v = u + at తెలుసు కాబట్టి నేను స్ట్రేట్ లైన్ ఈక్వేషన్ ఇచ్చేసారు. బట్ ఇక్కడ నాకు ఈక్వేషన్ తెలియదు. గ్రాఫ్ స్కెచ్ చేయడానికి ఎప్పుడైనా ఈక్వేషన్ తోనే స్కెచ్ చేయాలి. అదర్వైజ్ విల్ గెట్ ఎ రఫ్ స్కెచ్. అది లీనియర్ ఆర్ నాన్ లీనియర్ మనకు చెప్పలేము. అది లీనియర్ ఎలా చెప్పగలుగుతాను, ఈక్వేషన్ తోనే చెప్పగలుగుతాను. సో ఐ నీడ్ అన్ ఈక్వేషన్. బట్ ఈక్వేషన్ వచ్చే ముందు ఏమవుతుంది, ఫ్రిక్షన్ ఏమవుతుంది, ఇట్ విల్ కౌంటర్ బ్యాలెన్స్ F యాజ్ లాంగ్ యాజ్ F ఇస్ లెస్ దెన్ FL. నేను FL కెపాసిటీ ఉంది స్టాటిక్ ఫ్రిక్షన్ ది. సో FL కంటే తక్కువ ఉంటే F, ఇట్ విల్ కౌంటర్ బ్యాలెన్స్ F. సో టెన్షన్ ఏమవుతుంది, అప్పుడు టెన్షన్ 0 ఉంటుంది. టెన్షన్ డజంట్ కమ్ ఇంటూ పిక్చర్ అట్ ఆల్. సో టెన్షన్ 0 నే ఉంటుంది ఎప్పటి వరకు, when F reaches FL, till F reaches FL.
ఎస్
Once
సార్.
F is greater than FL, ఈ ఈక్వేషన్ రాస్తాను, FBD రాస్తాను. See, whole of Newton's laws is based on FBD. T, ఇది FL, ఇది F. Particle is in equilibrium. T plus FL is equal to F. T plus FL is equal to F. FL ని అక్కడ పంపిస్తా, T is equal to F minus FL. Y is equal to mx plus c. Negative intercept, positive slope. One is the slope. So this angle is 45 degrees. So the equation is, this is the equation. T is equal to F minus FL. For what? F greater than FL. For F greater than FL. For F less than FL or less than or equal to FL, T equal to 0. So my equation for the graph is this one. For F less than or equal to FL, T equal to 0. For F greater than FL, T is equal to F minus FL. Alright. So నేను ఈ ఈక్వేషన్ కాబట్టి నేను ఈక్వేషన్ ఇలా డ్రా చేయలేను. Alright, this is mathematically correct but physically wrong. ఎందుకంటే టెన్షన్ ఇక్కడ నెగటివ్ లేదు. Tension in string, negative tension in the string doesn't make sense. Alright. So tension is 0 till FL. After that it is equal to, it is varying like this as F minus FL. Alright.
ఎస్ సార్.
Okay. Coefficient of friction is mu. Okay. Mass is m. this mass is m naught. All right, ఎప్పుడైనా constants or known quantities are shown as knots. All right, NaUGHT or NOUGHT. All right, it is not NOT. It is not this knot. It is NaUGHT or NOUGHT. Knot means a circle. All right, మీరు XNOs ఆడతారు చూడండి, ఈ గేమ్ ఆడతారు. ఈ గేమ్ గుర్తుందా?
Yes, sir.
That's called X and O's, right? That's called knots and crosses. These are called knots, these are called crosses. So knots and crosses. So at E naught, E naught, not in a circle, right? Zero. That's called knots and crosses. That game is also called X and O's is also tic-tac-toe antaru, inkem antaru. There's different names, no? That's also called knots and crosses. So this M naught, usually what I use is for known masses, known quantities or constants, I'll use knots. So ikkada m naught ichanu, idi m ichanu. I have to find out m such that this particle is in equilibrium. Again, FBD. Let's say you are not able to understand anything. Em idea రావట్లేదు, నిద్ర వస్తుంది. All you have to do is draw the FBD and sit quietly. Things will automatically settle down. All right. నేనేమన్నాను? Particle is to be at rest. This particle is to be at rest. If this is at rest, this will also be at rest. If this is at rest, what is the FBD of this one? Tension T.
M
naught
naught.
G. So T is equal to m naught G.
Not G.
So దీనికి FBD ఎలా ఉంటుంది? ఇక్కడ m naught G ఉంటుంది because T is equal to m naught G. Now this is to be counterbalanced by friction, which is limiting friction. అంటే this is to be counterbalanced by friction కదా? So my m naught G should be less than or equal to limiting friction. Only then it can counterbalance. Friction can come into picture, static friction will come into picture. What is FL? Mu into m G. M naught G. G gets cancelled out. So m naught is less than mu into m. So mu is equal to m naught by m. If this is the ratio of mu, then it will remain at rest. Now let us see one example.
So,
This is, yes,
sir, can you tell me what is mean by mu?
mu. See, నేను experiment perform చేసినప్పుడు my static friction was proportional to normal reaction, right? This proportionality constant is my mu, which is the nature, which is the characteristic of the surface.
Okay, sir.
What mu is the proportion? Sorry?
Okay, sir. Constant అని అర్థమైంది ఇప్పుడు.
Okay. Proportionality constant, which is the characteristic of the surface. నేను surface మార్చేస్తే mu మారిపోతుంది. Alright? ఇది plastic surface పెడితే ఒక mu ఉంటుంది, rubber surface పెడితే ఒక mu ఉంటుంది. So some surfaces different, I change the surface, mu changes. So that's the characteristic of the surface. Okay, now let us see. So one thing you have noticed that G got cancelled out. Right? G got cancelled out అంటే if I take this in a lift, దీన్ని లిఫ్ట్ తీసుకెళ్ళి పైకి యాక్సలరేషన్ G తో మూవ్ చేస్తే will the particle move? Will the system move? చూడండి, G తో తీసుకెళ్తున్నాను. సో సూడో ఫోర్స్ ఫీల్డ్ mg కింద ఒకటి ఉంది. సో ఇక్కడ m naught G ప్లస్ G ఉంటుంది. సో ఇక్కడ 2mg వచ్చేస్తుంది. 2m naught G అంటే ఇది కూడా 2m naught G అయిపోతుంది. ఇక్కడ నార్మల్ రియాక్షన్ ఏమవుతుంది? 2mg అయిపోతుంది. సో లిమిటింగ్ ఫ్రిక్షన్ ఏమవుతుంది? 2μmg అయిపోతుంది. సో 2μmg should be greater than or equal to 2mg. See, 2g is again getting cancelled out. My mu is equal to m naught by m. So it is independent of G. See, whenever things are getting cancelled out, no, you can be a little careful. ఇంతకు ముందు కూడా మాస్ క్యాన్సిల్ అయింది. ఎప్పుడు ఒక పార్టికల్ ని ఒక ఫ్లోర్ మీద ప్రొజెక్ట్ చేస్తే వెలాసిటీతో V0 తో యాక్సిలరేషన్ ఏంటి అనుకుంటే నాకు మ్యూజీ అని వచ్చింది. వేర్ మాస్ ఇస్ గెటింగ్ క్యాన్సిల్డ్ అవుట్. దట్ మీన్స్ ఇఫ్ ఐ హ్యావ్ 1 kg పార్టికల్ ఆర్ 100 kg పార్టికల్, దే రిటార్డేషన్ విల్ బి సేమ్. సో ఒక 1 kg పార్టికల్ ని 10 మీటర్స్ సెకండ్ తో ప్రొజెక్ట్ చేస్తే, ఒక 100 kg పార్టికల్ ని 10 మీటర్స్ సెకండ్ ప్రొజెక్ట్ చేస్తే, రెండు both of them will stop at the same time because the retardations are same for both the particles. All right, mass is getting cancelled out there. Here also acceleration is getting cancelled out, interestingly. So my mu is dependent only on mass ratio of masses, not accelerations. I mean acceleration to gravity. Until the lift lo తీసుకెళ్ళినా కూడా it's going to be at rest. If it is at rest under gravity, it will be at rest in lift also. All right, but there is one small case there. We'll talk about it later. All right, so students, I'll leave you with a problem. We'll close in a minute. It's 8:30 already. Mu is 0.2. It is projected velocity 4 meters per second towards right. Find the velocity after 2 seconds. Find the velocity of the particle after 2 seconds. Mu of the surface is mu into the surface is 0.2. Applied force is 2 Newton. Velocity of projection is 4 meters per second towards right. And mass is 2 kg. Not 2 seconds, sorry. 4 seconds. Find velocity after 4 seconds.
Sir, okay, sir. Sir,
Sorry?
if you don't, if you had some more time, can you explain the static friction?
Yeah. Otherwise, we can do one thing. We'll continue tomorrow. What part of static friction you want? Like any case you want me to explain again?
No, sir. I mean, I want to understand the one briefly.
You want to understand? Sorry. Yes, Vignesh, you're saying something. You want to understand?
Sir, can you explain once again the static friction?
Yeah, static friction. See, we have not ventured into static friction much. Static friction will deal with static friction eventually, but kinetic friction at the moment, this deals with kinetic friction. Have you understood this problem?
Yeah, sir.
Okay. Let us quickly solve this in a minute. ఏమవుతుంది ఇక్కడ వెలాసిటీ ఇచ్చారు, సో kinetic friction is towards left. ఎంత ఉంటుంది ఫ్రిక్షన్? 0.1 ఇవ్వాలా 0.2 ఇవ్వాలి? 0.1 ఇస్తాను. 0.1 ఇస్తాను. ఓకే ఫైన్ 0.2 ఇస్తాను. 4 న్యూటన్ వస్తుంది కదా? యా 4 న్యూటన్. అండ్ దిస్ ఇస్ 6 meters per second. 4 న్యూటన్ వస్తుంది, విచ్ ఇస్ kinetic friction. నెట్ ఫోర్స్ ఇప్పుడు ఎంత వస్తుంది? 6 న్యూటన్. యాక్సలరేషన్ ఎంత వస్తుంది? 6/2.
2,
2,
3,
3.
3 meters per second.
per
ఏ
second
టైంకి
square.
ఆగుతుంది ఇది? 6 minus 3 into t equal to 0. V is equal to u plus at. U minus at. Acceleration is towards left, 3 meters per second square. Velocity is towards right, 6 meters per second square. So t is equal to 2 seconds.
4
Yes.
seconds.
So నేను అడిగాను velocity 4 seconds కి. నేను ఇక్కడ 4 సబ్స్టిట్యూట్ చేయొచ్చా? ఇక్కడ 4 సబ్స్టిట్యూట్ చేయొచ్చా? 6 minus 3 into 4, 12 minus 6. Minus 6 velocity ఉంటుందా? Can I say that?
Yes, sir.
Okay. Let us say ఎంత వచ్చింది నాకు 4 సబ్స్టిట్యూట్ చేస్తే? 6
In
minus 3 into
direction, sir. 6
Sorry?
meters per second in opposite direction.
in opposite direction 6 meters per second వస్తుందా?
Yes, sir.
ఓకే లెట్ us see. చూడు ఈ 2 seconds తర్వాత ఏమవుతుంది? ఆగిపోతుంది బ్లాక్ ఆగంగానే applied force is 2 Newton, kinetic friction gone, disappeared, static friction will come into picture, limiting value is 4 Newton, but applied is only 2, self adjust to 2 Newton. So net force now is 0. If net force is 0, velocity is 0, particle will remain there itself. Velocity will be 0 forever. 2 seconds కి 0 అయిపోతే 4 seconds కూడా 0 అనే ఉంటుంది, ఎందుకంటే పార్టికల్ కదలలేదు.
Yes, sir.
Alright, so I cannot plug in directly from here because law is changing. ఇక్కడ 6 - 3t ఎప్పటి వరకు ఉంది, ఆగిన వరకు. అప్పుడు ఆ మూమెంట్ తర్వాత ఫోర్స్ చేంజ్ అయిపోయింది. సో లా చేంజ్ అయిపోయింది, ఈక్వేషన్ చేంజ్ అయిపోయింది, ఈక్వేషన్ ఆఫ్ మోషన్ హస్ చేంజ్డ్.
Yes, sir.
Alright, so be careful in kinetic friction problems. ఎప్పుడు kinetic friction ఉంటే it's easy to handle because velocity ఉంటే I can still stops anywhere, kinetic friction will disappear, static friction will come into picture. Alright, so there lies the crux of the problem. అక్కడ ట్విస్ట్ వస్తుంది ప్రాబ్లమ్ లో. So there you have to be careful. Alright, so let's continue with this problem tomorrow. Okay, any doubt here? Students, any doubt?
No, sir.
Vignesh, we'll deal with static friction anyway. Alright, we are not completed static friction. Chase static friction. Lot to do, we'll do it.
Okay, sir.
Okay, but you have understood all the cases till now, na? If you haven't understood,
Yeah,
you
sir.
please revise. You can ask me again in the next class.
Sure, sir.
Alright. So bye everyone then. Good night.
Bye, sir.
Bye. And Bhavna, you were not there for morning classes. Any problem?
No, sir, I was there, sir. Today's
Oh,
school.
not today. Like couple of days before.
Yes, sir.
So network issue or health issue?
Sir. Network, sir.
Okay, if there is any issue which we can resolve, let us know. All right.
Okay, sir.
Chalo then. Bye everyone. Good night and good luck.